Hello everyone. Welcome back to our IoT learning series Internet of Things. In this session we will explore the Unit 5 Interface Electronics and Future Scope of a Smart Sensor. In the world of IoT, sensors are only as good as electronic circuits that connects and communicate with them. That's why today we will understand how interface circuits help smart sensors to interact with IoT systems. We will discuss the challenges faced while integrating the sensors with diverse platforms. After that, we will explore the role of silicon technology in building the advanced smart sensors. Finally, we will take a look at the future trends and the research areas in the smart sensor technology. Stay tuned till the end to get a complete grasp of this exciting topic. So let's begin our journey. At first, interface electronic circuit for a smart sensor. Interface electronic circuit act as the crucial link between the smart sensor sensing element and the IoT system. These circuits handle the signal conditioning, amplification, filtering, analog to digital conversion. Since sensors detect the physical changes, their signals often require amplification and noise reduction before further processing. Common interface components include operational amplifier, ADC, DAC, filters, multiplexers. Some circuits also perform linearization and calibration to enhance the sensor's accuracy. Modern smart sensors often have on-chip interface circuit to reduce the size and improve the integration. The use of low power and wireless modules ensures sensors can operate in remote or battery powered system. Good interface circuit design improves the data quality, reliability and overall system performance. Without proper interfacing, even the best sensors can fail to deliver the usable data. This makes the interface electronics a vital part of every smart sensing application. Challenges in interfacing smart sensors with IoT system. While integrating smart sensors into the IoT system, several challenges arise, especially due to diverse communication protocols, hardware constraint. One of the biggest issues is signal compatibility, where sensor outputs might not match the system's input requirements. Power management is another major concern, especially in the wireless and remote applications. Sensors also produce noisy, nonlinear, and weak signals that need careful conditioning. Latency and bandwidth limitations can affect the real-time data transfer and cloud synchronization. Moreover, interfacing different types of sensors often require multiple data buses and conversion circuits. Ensuring security and data integrity while transmitting sensor data over network is equally critical. Physical size constraints also limit the complexity of the interface circuit in compact devices. Finally, maintaining the cost effectiveness and scalability while meeting the performance demands adds to the complexity. Addressing these challenges is essential for smooth deployment of IoT based sensor network. So, usefulness of silicon technology in the smart sensor development. Silicon technology has played a pivotal role in advancing the smart sensor design and performance. Silicon based semiconductors are widely used for fabricating the microcontroller, ADC, wireless modules, and signal processors. Within the smart sensor, its compatibility with CMOS, complementary metal oxide semiconductor technology, allows for the development of low cost, compact, energy efficient smart sensor. Silicon sensors such as MEMS, micro electromechanical system, have enabled the miniaturization of sensor for applications in the healthcare, automotive, and industrial IoT. Integrated circuits built on silicon wafers provide the computing and communication capabilities needed for a smart sensor. Silicon's high reliability, thermal stability, and scalability make it an ideal material for developing the complex high performance sensors. Additionally, silicon photonics and nanoscale transistors are opening the new avenues in the sensor integration and processing speed. This makes the silicon technology indisciplinable in the evolving landscape of a smart sensor development. Future trends and scope. The future of smart sensor is geared toward greater miniaturizations, ensured connectivity, and artificial intelligence integration. Emerging trends include the development of cell powered and energy harvesting sensors for remote and wearable applications. AI enabled smart sensors capable of local decision making are being designed for healthcare, agriculture, and industrial monitoring. Another significant trend is the rise of flexible, stretchable, and biodegradable sensors for wearable and environmental sensing. Integration of 5G and edge computing will further reduce the latency and improve the real time analytics. Research is also focusing on multifunctional sensors that can simultaneously detect the multiple parameters like the temperature, humidity, and pressure. Quantum sensing and graphene based devices are areas of intense investigation for next generation sensor technology. Additionally, secure and encrypted sensor network are becoming crucial to address the IoT security challenges. So the further future holds immense potential for innovative, adaptive, and intelligent smart sensor solutions. So that's wrap up our today's session on interface electronics and future scope of a smart sensor. We explored how interface circuits connect the smart sensor to IoT system and the common challenges faced during the integration. We also introduced the critical role of silicon technology in the modern sensor development. Finally, we took a look at the emerging trends and the exciting research area shaping the future of a smart sensor. I hope this video gave you a clear and practical overview of this important topic. Don't forget to like, comment, and share this video if you found it's useful. Subscribe to this channel for more IoT insights and tutorials. See you in the next unit. Until then, stay curious and keep learning.